Hello, 8th graders. Here's another lesson on our square roots. We're going to start with simplifying again because that's very important that we have that down. We'll try one of the addings just because I know people are having trouble with that one. And then we'll move into cube roots and fourth roots, which are higher up than the square roots. So it's very important that we know our perfect squares here, the 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And it might go higher than that. We've got 121 is 11. We've got 144 is 12. We've got 169 is 13. 196 is 14. 225 is 15. And we don't usually see stuff over that. So when I give you a number like 108, we're asking what goes into it. So it would have to be lower than 108. So it's definitely on my list over here on the right side. 100 doesn't. 81 doesn't. 64 looks like it might, but it doesn't. 49 doesn't. None of these are springing out to me. So I would like to show you an idea here. It's a factor tree. So what goes into 108? Well, I know 2 goes into it 54 times. I'm going to scan my list. 54 is not on my list. So I could do it again. 2 goes into it 27 times. 27 is not on my list. 3 goes into this 9 times, and I'm going to pause there. So 9 is on my list, and then actually if I put these two together, that would make 4, which is on my list. So let's just put that all together. 4 times 9 is 36. So let's use 36 as our perfect square. And then what was the thing that was left? The only thing I didn't use was that 3. So what makes 36 is 6 times 6, and then the 3 is going to stay forever alone inside the root. And that is our simplified answer, 6 square root of 3. Square root of 200, some of these hopefully just pop right out at you. What goes into 200? 100 times 2. So what makes 100 would be 10, and then that 2 is going to have to stay forever alone inside the square root. So take a second and consider 24. What goes into 24 from our list? And remember, it's got to be smaller than it. So I'm looking at this set right here, 16, 9, and 4. What number goes in would be 4 times 6. What makes 4 is 2 times 2, and then that's 6. I got those colors backwards, didn't I? I'm sorry. The 6 is going to stay forever alone inside. Okay, 338, that is another one that I look at and it doesn't spring right to mind what it could be. So I'm going to try breaking it down. So 2 goes into that 169 times, and there it is. 169 is one of our perfect squares that I mentioned at the beginning. That's beyond our 10 by 10. 169 is 13 times 13, and then that 2 is going to stay inside the radical. Okay, so this is what we ended last lesson on, and it was challenging. Some of you have just typed it in the calculator and given me a decimal, and that is not what I'm looking for. We are looking to simplify this, add it, and get it as small as we can without actually getting the decimal. When you pick the numbers, they have to be on this list over on the right side. You can't use something else. So like with 12, I can't say 6 times 2 because 6 is not one of these numbers over here that's perfect. What I would have to use is 4 instead, 4 times 3. 810 seems intimidating until you notice which number goes really nicely into it. How about 81 times 10? What makes 27 from our list? That would be 9 times 3. What makes 640? That would be 64 times 10. Okay, now we're going to go through and get our answers there. What makes 4 is 2 times 2, with the 3 staying inside. What makes 81 is 9 times 9, with that 10 staying inside. What makes 9 is 3 times 3, with that extra 3 staying inside. What makes 64 is 8 times 8, with that extra 10 staying outside. And I need signs, so since they're all positive, I'm just going to use plus signs. Now I'm going to look for ones that match. So 2 radical 3 and 3 radical 3 both have that radical 3. So I'm going to add 2 of them plus 3 of them and get 5 of those same thing. Then I've got 9 radical 10 and 8 radical 10. They're both radical 10, so I'm going to add 9 and 8 and get 17 radical 10. Now, please do not do anything else. That right there is our goofy looking answer. If we typed it in with a calculator, we would get the same thing if we just went ahead and got that decimal. But this is called simplifying, and that's where we want to stop. Okay, so our new thing today is cubes. Cubes means that we're doing it 3 times. So this first one is 1 times 1 times 1, which is 1. And I've got 2 times 2 times 2. Be very careful and please don't say 6, because 2 times 2 is 4, and 4 times 2 is 8. Okay, so 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is 64. 5 times 5 is 25, and 5 quarters is $1.25. 6 times 6 times 6 is 216. And drop into the bottom, 10 times 10 times 10 is 1,000. We could go to a calculator and get these other ones. For example, 7 times 7 times 7 is 343. But I have never seen these ones come up right here. And if they did, you could just use a calculator to figure out what they are. These are the ones that you should be able to calculate yourself or be able to recognize. So the opposite of a perfect cube would be a cube root. Just to be silly, here is a picture of a cube root. It is a tree that grew inside a concrete box. So the root just filled up that box, all that space that it had, and then the box broke. So here is a literal cube root. And here is what a cube root really looks like. So the radicand is the number you're trying, like 8. The radical symbol is still the same, and then this index is new. So when we used to do like square root of 81, there was always a little invisible 2 here that we don't write just because we do square roots so much. So that's saying what 2 times makes 81. This one is saying what 3 times makes 8. And as you can guess, we could change that number and have 4, 5, 6, 7, 8, anything in there. So here's a few to try. What 3 times makes 8 was 3 2s. And we just write it once. It was 2 times 2 times 2 made 8. So the 2 is the answer. What 3 times made 1 was 1 times 1 times 1. What 3 times makes 64? That's a harder one because you don't think it should be that big. But these get big rather fast. This is 4. 125, that 5 should be the hint there that it is 5 times 5 times 5. And this one right here is not perfect. So it does not have a single answer. If you typed it in your calculator, you would get a decimal. We could simplify it like we done. Notice please that this one goes into it, so we could simplify it, but we are not going to do that right now. I just wanted to give you an example to show you that they don't all work, but the ones on your homework all do work out. Okay, we also have fourths. This is 4 times. This is 1 times 1 times 1 times 1, which is 1. 2 times 2 times 2 times 2. 16. Notice how big this one's getting already. Personally, just the mental math that I'm doing, I say 3 times 3 is 9, and 3 times 3 is 9, and then I do 9 times 9 is 81. So like this next one, 4 times 4 is 16, and 4 times 4 is 16. So I'm doing 16 times 16, which is 256. This is 5 times 5 times 5 times 5. I'm going to skip these ones and go down to 10. 4 tens makes 10,000. Again, these middle ones do not come up. I've never seen these ones come up. And if they do, you'd have a calculator that you could give it a try. So here is our 4th root of 16. So that's saying what 4 times made 16? That is 2's, because 2 times 2 times 2 times 2 is 16. So what 4 times made 16 was 2. I'd like you to give this a try on the homework tonight, 7.4. It's going to have some simplifying like we did at the beginning. It will not have adding, so don't worry about that. It'll have some cube roots and 4th roots. If you don't recognize them, feel free to rewind this video and just go back to that spot where I've got them on the screen and just look for them. You could try calculating them out, whatever works for you.